Hello, Honors Algebra 2. In this video lesson, we will be discussing data displays, sometimes called data representations or data visualizations. Any way you want to call it, it's just a way to take a snapshot of the data and present it so people can understand it in a quick and easy format. You'll quickly see, though, some data displays are better for different types of data, and some are easier to understand for different purposes. The two types of data we want to consider are qualitative, data based on qualities, or quantitative, data based on quantities. I'm sure you've discussed this in science classes previously, but you're talking about things that can be defined using a category, like what's your gender, what's your race, what town do you live in? So some questions that might produce a qualitative response would be things like, what do you drink? Do you pick from the vending machine? Guernsey chocolate milk or Guernsey lemonade? Maybe that changes from month to month. What's your favorite TV show or genre of TV shows? What's your zip code? Seems like it would be a number, but that's actually qualitative because it's a category of an area in which you live. Quantitative data has this numerical element to it. Quantitative data is the data you get when you ask questions like how many, how much, how often, how many cups of coffee do you drink each week, how much do you sleep each night, how many people live in your house. All of these answers may have changed drastically in the last month or two as the quarantine and isolation period has begun. So some ways you can display qualitative data are with pie charts. Whatever has the biggest slice of pie is the category that got the most responses. The smallest slice of pie got the least responses. Sometimes these are called circle graphs. I'm sure you made some of these in elementary school, or at least had to read some. Another way you could present the same data is with a bar graph. A bar graph will show you still that basketball had the most responses, but it also allows you to see how close baseball and football actually were in a way that the pie chart didn't so much. And it may not have so much, if you look back, partly because of the color. That yellow really sticks out, even though it's 4% less than the baseball sector. Another way you could present the same data is with a pictograph. Really just a bar graph with pictures. It catches your eye. It's great to put on a presentation because you can easily see, oh wow, basketball's the most, soccer's the least. But without the chart to go with it, or without some sort of scaling on the side, sometimes it's hard to tell how much there is actually a difference. Quantitative data can be displayed using several different types of displays. One of those displays is a stem and leaf plot. In a stem and leaf plot, the stem is the column on your left. It's the part that the category shares, and the leaf is the part that makes it different. So for instance, the 0 tens category, I have 1 and 5. In the 1 tens category, I have 2 tens. In the 2 tens category, I have 3 zeros for 20, 20, and 20, and 5 fives for 25, 25, 25, 25, and 25. In the 30s category, I have 3 zeros for the 3 30s. In the 40s category, I have 3 zeros for the 4 40s. And in the 50s category, I have 2 zeros for the 2 50s. This still allows you to see the specific data, but it also allows you to make generalizations. Like, wow, there are a lot of people that responded. On average, how many texts do you send a day? They responded that question with a value in the 20s. That can be powerful. It gives you a big picture with specific details. However, some people can find stem and leaf plots easy to misunderstand or not quite gain the right view of the data. Some people start looking at this and think, ones, tens, hundreds, and they read this as a very large number. So it can cause some confusion for some people. A dot plot, we're still going to want to label it out, but a dot plot is a way to represent the data by taking the number out and representing each number with a dot. I'm going to use a highlighter as my dot because it's the easiest one for you to see. But I could put a dot for my 1, put a dot for my 5, 2, oh, that one's off a little. 2 dots for my 10, 1, 2, 3 dots for my 20, 5 dots for my 25, 3 dots for my 30, 3 dots for 340s, and 2 dots for 250s. And I know those dots aren't perfectly drawn, but you can still see that a huge portion of the data is between 20 and 30, being most people are sending on average between 20 and 30 texts a day. A frequency table starts pulling away the specifics and focusing on the generalities. So, for instance, you're going to build categories. Sometimes they're called bins, and say, okay, 0 to 5, there were 2 pieces of data there. 6 to 10 has 2 pieces of data. 11 to 15 has no data values, no entries or items in that time. 16 to 20 has 3. 21 to 25 has 5 25s. 26 to 30 has 3. 31 to 35 has none. 36 to 40 has 3. 41 to 45 has none. And 46 to 50 has the 250s. The downside to a frequency table is you lose out on the specific values. So you don't realize that all 5 of the items in this bin or category are all 25s. However, you still gain that idea that the majority of data is in this middle section here, or majority of the responses. The histogram is like the bar chart for qualitative data, but there's no gaps between bars. And a histogram is based off that frequency table. You could also make a relative frequency table by finding percents compared to the whole, and a relative frequency histogram using those percents of the whole. So in this case, we're just going to make a pure histogram. And if we section this off by 10, 20, 30, 40, 50, and we can count 2, 4, 6, and 8. I'm going to change this to the highlighter pen because it's going to be easier to make bars this way. But I can say, oh, between 0 and 10, I have 4 data values. So I'll make a bar of 4. From 11 to 20, I have 3 bars. From 21 to 30, I have 5, 6, 7, 8. Very large bar, just like the rest of the data displays have shown. 31 to 40, I have 3. And 41 to 50, I have 2. Again, we can still get that gist that the majority of the responses were in that section between 20 and 30, but we don't have any of the specifics in a histogram. The last quantitative data display is a box and whisker plot. A box and whisker plot is based off of something called the 5-number summary. And the 5-number summary is a min, the Q1, median, the Q3, and the max. We discussed those last week, I believe, in some of the cons. So this 5-number summary, your min is 1, your max is 50. The median is the average between the 10th and 11th value because 20 has an even number of values, 20 values. The middle is going to be between 10 and 11, so that median is 25. 1, 2, 3, 4. The average between the 5th and 6th value, 20 and 20 is 20. And the median of the upper half, 1, 2, 3, 4, 5. Median, you're going to have to find the average between 30 and 40, which gives you 35. So then you're going to graph them out. 30, 35, 40, 45, 50. One would be mark at 20, a mark at 25, a mark at 35, and a mark at 50. The middle is your box, and the end is your whiskers. The great thing about a box and whisker plot, part of the reason it's used so frequently, is because it takes out all the specifics, but it leaves some. You still know where your min and your max are, and you still know where that median is. You also can quickly see where the data is spread out and not spread out, because a box and whisker plot breaks data into 25%. So you can look through and say, oh, the data is most condensed in this section and most spread out in this section. Because if 25% of data is a small area, it's condensed. And if 25% of the data is in a larger area, it's more spread out. Something else we often look at is something called this IQR range, the middle 50%. It's really helpful. I'm not less concerned on a test for who's in this bottom 20 or who's in the top 20, bottom 25 or the top 25, and more concerned, where did that middle 50% fall? Above average? At average? Below average? It tells me a lot about where that middle portion lies. I hope this lesson on qualitative and quantitative data displays helps you get a clear picture of different ways to display data. For the Khan assignment this week, I actually only assigned the exercises, quizzes, and I believe there's a unit assessment at the end. I didn't even assign the Khan videos because I feel like this video summarizes the majority of it. If you start doing a Khan goal and you're struggling, you could certainly click on the video below the question or take a hint, and that might give you what you need to keep going. If it's not, go back and look at those videos. But I wouldn't focus so much on watching them and focus more on actually doing the questions. I hope this helps.